Good evening. My name is Christina Fennell from the Bioinformatics class for Dr. Chen, and today I'm presenting to you my final bioinformatics presentation. I also did this project with Mason Dana. So for background information, for this project, we studied the SOX4 gene. It's a transcription factor that allows for normal embryonic development. And when SOX4 is mutated, degenerative disorders and cancer may occur. For this project, the data collected came from exploring the impact of wild-type SOX4 transcription factor and SOX4 in its mutated form within mice. For our methods, we've downloaded the data from the NCBI website and imported it into the RStudio program to be analyzed. Numerical data was extracted from the provided data set, and the means of the SOX4 wild-type data and the CKO mutant data were calculated, and the box plots were created to determine the distribution of the data. Then we used the correlation function between the wild-type and mutant genes to determine and explore similarities between the genes. Then t-tests were performed for each of the wild-type and mutant genes to determine the p-value and statistical significance of the data. And lastly, the histograms and density curves were created to analyze the distribution of the p-values and q-values to ultimately verify the significance of the data. So first, for our results, this was the box plot that first appeared for the distribution of the genes. And we see here that there seem to have an even distribution across each gene. And this is verified within the data tables of the box plot information, where the minimums, the first quartiles, the median, mean, third quartiles, and the max values are all about the same. And for the correlations of the wild-type mutant genes, the correlations are all about 1, which indicates that they're all about pretty equal correlation between the wild-type mutant genes. And this is a histogram of the p-values from the different genes in our data set. We're also able to use the data density curve to show that most of the p-values lie between the values of 0.1 and 0.2, meaning that most of the p-values within our data are not significant. Here is a histogram of the q-values that represent the false positive, and you can see it's mostly around the 0.6 and 0.7 value. Here is the distribution of the q-values in table format, and you can see just briefly the layout of the q-value distribution. Here is another table that showed the significant p-values within the first 50 genes that we analyzed, and we found that within the first 50 genes that we analyzed, 2 of them had significant or marginally significant p-values of 0.04 and 0.06. And the q-values are the same as well. So ultimately, from this data, we can determine that the significant p-values demonstrate that the SOX4 transcription factor does play an important role in the normal organismal development. And we also found that further analysis on other developmental genes can help regulate human development in the future. Thank you for listening, and here are the references.